Well, in our last video of this section, we're going to do one more example where we solve a system of equations using matrices, and we're going to use the Gauss-Jordan Elimination method. So this time, though, notice we have four equations with four unknowns. We're going to have variables w, x, y, and z. So our column labels, w, x, y, z. Those are the columns. I took the liberty of writing the augmented matrix associated with this, so you can go through and check them. Notice that the top one, the coefficients would be 1, 1, 1, 1, followed by a 5. And you can go ahead and check and make sure I did all of that correctly. Now, as with several of our examples, we lucked out. The very first baby step we have to do is to convert this into a 1. But turns out that it's already a 1, so that step was done for us. So now we need to use that 1 to get zeros below. So in this, I'm going to subtract row 1. In this one, I'm going to subtract row 1. In this one, I have to subtract 2 times row 1. And that will give us all zeros below it. So let me write that down. Row 2 minus row 1. Row 3 minus row 1. And row 4 minus 2, row 1. And those are the three row operations that will give us zeros underneath. And once again, I've already mentioned this, but notice we have a 1 and a 1 and a 2. And here we have the number being multiplied by r as a negative 1, r times r1, negative 1 times r1, negative 2 times r2 to cancel out the 1, 1, 2. Okay, so now row 1 does not change. Row 2. So it's pretty easy. We just need to subtract 1 for all these four ones. We need to subtract a 1 from all of these four. So that would give us a 0. 2 minus 1 is 1. Negative 2, because it's negative 1 minus 1. And then negative 2 minus 1 gives us negative 3. And then finally on the right side here we get negative 1 minus 5, negative 6. Third row we do the same, just subtract row 1 from it. 1 minus 1 gives us a 0. Negative 3 minus 1 gives us negative 4. Negative 3 minus 1 gives us another negative 4. Negative 1 minus 1 gives us a negative 2. And negative 1 minus 5 gives us negative 6. Last row. So notice that minus 2 row 1. We're going to subtract the double of this. So 2, 2, 2, 2, 10 is what we'll subtract from this row. So 2 minus 2 gives us 0. Negative 1 minus 2 is negative 3. 2 minus 2 is 0. Negative 1 minus 2 is negative 3. And finally, negative 2 minus 2 times 5. Negative 2 minus 10 gives us negative 12. All right, let's see if I'll squeeze in one more matrix alongside here. But we've done great. We got this 1, and then we zeroed out everything below it. So what's the next number that needs to change? Well, ordinarily, this one has to change into a 1. But somehow we got lucky, and it ended up being a 1 by itself. But for example, if it ended up being a 2, we would need to turn it into a 1 by either dividing by 2 or using rows below it to try to turn it into a 1. But it is a 1. And I do want to emphasize that comment. If this weren't a 1, you never go upstairs. For example, if we were to add or subtract row 1 into this row, it would clobber this 0, which we worked so hard to get. So from here down, if this weren't a 1, you need to use rows below it to convert that into a 1. But it is a 1. So let's use that 1 to get zeros above and below, which means row 1, all we need to do is subtract row 2. If we keep following this recipe, it works every time, because notice in doing this, when we do that subtraction, this 1 is not going to change because we have a 0 below it. We can't clobber these 1s that we created, and we can't clobber any of the zeros that we have created. So row 1 minus row 2 is going to give us a 0 there. How about for row 3? Well, it's a minus 4, so we have to do a plus 4, row 2. And that would give us a positive 4, so adding them would give us a 0. And then row 4, it's got a negative 3, so we have to do plus 3 times row 2. All right, so row 2 didn't change. I'll go ahead and just fill that in. 0, 1, negative 2, negative 3, negative 6. All right, row 1. Just subtract row 2, which means do this minus this, this minus this, this minus this, this minus this, this minus this. So 1 minus 0 is a 1. 1 minus 1 is a 0. That's why we picked this row operation, was to get that 0. 1 minus negative 2 is 1 plus 2, which is 3. 1 minus negative 3 is 1 plus 3, which is 4. And 5 minus negative 6 is 5 plus 6, which is 11. Go down to row 3. We're adding 4 times row 2 into this. 4 times row 2 would be a 0, 4, negative 8, negative 12, negative 24. We're adding that into this row. So 0 and 0 is 0. Negative 4 plus 4 times 1 gives us a 0 as well. Negative 4 plus 4 times negative 2 is what? 4 times negative 2 is negative 8. Negative 4, negative 8 gives us negative 12. All right, then negative 2 plus 4 times this. Well, 4 times this is negative 12, and negative 2 gives us negative 14. And then negative 6 plus 4 negative 6s. 4 times negative 6 is negative 24, and negative 6 gives us negative 30. All right, last row. Adding 3 times row 2. So we're really going to add, into row 4, we're going to add 3 times this. 0, 3, negative 6, negative 9, negative 18. So 0 and 0 is 0. Negative 3 and 3 is 0. 0 and 3 times this is negative 6. Negative 3 and negative 3 times 3 is negative 9 plus negative 3, negative 12. And then negative 12 plus 3 times this. 3 times this is negative 18. Negative 12, negative 18, negative 30. All right, so we really have an option here, but I'm going to keep going straight forward through the little recipe that we know. I'm going to convert this into a 1, this negative 12, by dividing the whole row by negative 12. I want to make you aware of another option. If you really want to avoid fractions, at least delay them. Notice if I divide this whole row by negative 12, I'm going to get a fraction here and a fraction here. But that's okay. It's not going to slow us down at all. But if I didn't want fractions, if I absolutely didn't, I could notice that the bottom row, if I divide the whole bottom row by negative 6, this would be a 1. And this would be a 2, and this would be a 5. I could just switch the rows then, and it would give me a 1 here. So there are some things you can do. Again, don't start looking upstairs. You always look downstairs when you're trying to create a 1. I'm going to go ahead and just do this. I'm going to do negative 1/12 row 3. And that's going to give me a 1 right here. And again, if you wanted to write this as row 3 divided by negative 12, that's the same thing. So let's write that matrix down. So it's going to stay, row 1 stays the same. 1, 0, 3, 4, 11. Row 2 stays the same. 0, 1, negative 2, negative 3, negative 6, no change. And the bottom row stays the same. And then finally, I'm going to divide all this by negative 12. So 0, 0, 1, right? Because negative 12 divided by negative 12. What's negative 14 divided by negative 12? It's positive. 14 over 12 is really 7 over 6 if you reduce it. And negative 30 divided by 12, negative 12 would be a positive number, 30 over 12. We could divide them both by 6 and get 5 over 2. All right, doing good. We just created this third number 1. And we're going to use it to zero out everything above and everything below it. So I'm going to do row 1 minus 3, row 3. And again, it's a minus 3, row 3, because we have a 3 here. The minus 3, when you multiply this by 3 and subtract it, it's going to be a 0 here. And here we'll have to do a plus 2, row 3. Row 2 plus 2, row 3. And then below on row 4, we'll do row 4 plus 6, row 3. Okay, so the only one not changing is row 3. 0, 0, 1, 7 over 6, 5 over 2. Okay, row 1 minus 3, row 3. Let me see. I'm going to use some scratch paper over here, so in my next matrix I'll write down below. This will be scratch paper. I'm going to write down what negative 3, row 3 is. Negative 3 times row 3 will be a 0, 0, 3. And then what's 3 times 7? 21. 21 over 6. 21 over 6 reduces. You divide them both by 3 to get 7 over, see, what are we doing? We are multiplying by negative 3. So that's actually the 3 and the 6 would cancel, giving me 7 over 2. And would it be positive or negative? I've forgotten what I'm doing. Negative 3, row 3. So it would be a negative 7 over 2. And then multiply this one by negative 3, you'd get negative 15 over 2. All right, so that's negative 3, row 3, and I need to add that in since we did the negative sign. That would actually be a negative 3, right? So if we multiply this by negative 3, we'd get a 0, 0, and a negative, negative, negative. And that looks good. So let's add this into row 1. So we'll get a 1, 0, 3, as 3 and negative 3 gives me 0. And now what's a 4 plus negative 7 over 2? That's negative 3 and a half. So 4 minus 3 and a half just gives me a half. And then 11 minus 15 over 2. 11 is 22 over 2. 22 over 2 minus 15 over 2 gives me a 7 over 2. All right, we're doing great. Row number 2. Let me write down what 2 times row 3 is, since I need it here. 2 times row 3 is 0, 0, 2. 2 times row 3. The 2 would cancel, giving me 7 over 3. And the 2 would cancel, giving me just a 5. So 2 row 3, I need to add this into row 2. So 0, 1, 0. Fourth term, negative 3 and 7/3, adding 7/3. Okay, negative 3 is negative 9 over 3. Negative 9 over 3 plus this gives me negative 2 over 3. Okay, and then negative 6 plus 5, well, that's just negative 1. All right, row 4, we're getting very close. Row 4, plus 6 times row 3. Let me write down what 6 times row 3 is, although this is pretty easy. 6 times row 3 will be 0, 0, 6. 6 times 7 over 6 is a 7. 6 times 5 over 2, the 6 and 2 cancel to 3, which gives me 15. So add this into row 4. So 0, 0, 0, 0, 0, 0. And then negative 12 and 7 is a negative 5. And then a negative 30 and 15 is negative 15. Beautiful. All right, so what is the next thing that we have to do? We got a 1 here, got all zeros below. Went down the diagonal, got a 1 here, zeros above and below. Went down the diagonal, 1 here, zeros above and below. Now we've got to turn this negative 5 into a 1. And by the time you get to the last row, this one, there's only one way to do it. You just divide the whole row by this number, negative 5. So I'm going to cheat. Rather than writing a whole brand new matrix to convert this bottom row into 0, 0, 0, what would it be if you divide by negative 5? Here and here. 1, 3. I'm just going to do this. 1, 3. And pretend like I wrote a whole new matrix to do that. And what we did right there was negative 1/5 of row 4. To do this, which is perfectly a valid row operation. So now that we've got a 1 here, we've got one more matrix to do. All we have to do is zero out above it. Okay? So let me write this matrix. Well, let's write the row operations here, and then I'll write the matrix below. This is all my scratch work. All right, so I'm going to put row 1, and I have a half here, so I have to do minus 1/2 times row 4. Row 2, I have a minus 2/3 here, so I have to do a plus 2/3 row 4. Row 2 plus 2/3 row 4. Row 3, I need this 7 over 6 to be a 0, so I need to subtract 7/6. So I'm going to do minus 7/6 times row 4 for row 3. Row 3 minus 7 over 6 row 4. I'm going to remember this was for the previous step. We've already done that. So our last final matrix. The only row that does not change is the bottom row. 0, 0, 0, 1, 3. So the bottom row already tells us what z is. 1z equals 3. Z is a 3. All right, let's go upward. So let's start with the third row. Row 3. So remember what we're doing here. Minus 7/6 times row 4. Well, 7/6 here would be a 7/6 and then 21 over 6. And we're going to subtract that from this row right here. So 0 minus 0, 0 minus 0, 1 minus 0. So we get a 0, 0, 1. And then we should get a 0 here. 7 over 6 minus 7 over 6 times 1. That gives us a 0. Now we've got 5 over 2. This will be my more scratch paper. Minus 7 over 6, which is 7 over 6 times 1, really. With 7 over 6 times 3, which I'll write like 3 over 1. All right, again, we're working on this guy right here. So it's 5 over 2 minus 7 over 6 times this thing in row 4. The 3's cancel. 3 and the 6 cancel. That becomes a 1. That becomes a 2. What is 5 over 2 minus 7 over 2? Negative 2 over 2. Negative 1. Okay. Let's go to row 2. Row 2. We're going to do row 2 plus 2/3 of this. Well, 2/3 of that, I'll go ahead and write it down since I didn't on the previous one. 2/3 of row 4 is very simple. 0, 0, 0, 2/3. And what's 2/3 times 3? 2/3 times 3, the 3 cancels and we get a 2. Simple as that. So we're going to add this into row 2. So we're going to get a 0, 1, 0. Add these, add this, add these. That gives us a 0. Negative 2/3 and 2/3. And then negative 1 and 2 gives us a positive 1. All right, top row, and it'll finish us off. Negative 1/2 of row 4. I need it right here. So negative 1/2 of row 4 is 0, 0, 0, 1/2. And then 3 over 2. So add that into row 1, and I think that'll finish us up. So we get a 1, 0, 0, negative. That's a negative and that's a negative. I multiplied by negative 1/2, so both of these are negative. So now I'm adding it into row 1. 1, 0, 0, 0, 1, 0, 0, 0. And lastly, 7 over 2 added to negative 3 over 2 would be a positive 4 over 2, which is 2. Whew. That was a lot of arithmetic. So what is the solution? The solution is, well, the bottom, right here we know z is 3. Right here we know that y is negative 1. Here we know x is 1, and we know that w is 2. So the nice way to write that would be as an ordered 4-tuple, starting with w, 2, 1, negative 1, 3. That is the solution. Now, if you were doing a homework or doing an exam and you had some extra time, you could plug these in to all 4 of these equations to verify that they work. I'm not going to do that now, but let's do the first one only because it's so easy. The 4 variables, w, x, y, and z, should add up to 5. And our solution says 2 and 1, well, the 1 and negative 1 cancel out to 0, and then 2 and 3 give us 5. So I'll let you check out all of the other ones. Let's take one last look at this problem. So what did we do? The beginning matrix, and then we needed 1, 2, 3, 4. 5 additional matrices. Not too bad.